you so much, and thank you for that very nice introduction. I have a long history and deep connection to SAFs, and so I wanted to before I got going and we get into the weeds about climate-informed management and what we can do to adapt to climate change. I wanted to take a minute to thank folks that have really helped influence my trajectory to this point. And I started writing out the slide, and it became like 8 slides long. And so what I did is I cropped it, but this is meant to capture some of the flavor of people that I encountered at SAF, starting as an undergrad, then doing grad school, then postdocing, and many of the mentors and people that have helped influence me in a great way, good ways, are sitting in the room. They've walked the halls, and I wouldn't be the scientist I am now without having had all those wonderful interactions. So I have a very close connection to SAFs. You will see as we go through and review some of the things that I've worked on, you'll see that many of my collaborators also have strong ties back here to the school. It is a wonderful community. So I wanted to thank SAF's community in general. My mentors, of course, Dave Armstrong was my advisor. Dave and Jan became my sort of adopted parents in the academic sense. And then a number of people like Daniel and others that knew me as undergrads and were that sort of opened the doors into fisheries science. And then I also like to thank my AFSC collaborators and mentors as well, especially Ann Hollywood and Karam Aiden, Jim, who's sitting here, has been a wonderful mentor, and of course many others. And then I've listed some because I am from, this is my daughter's acronym for NOAA. I am from NOAA, so I've listed some of the larger groups I work on: IEA, CFI, we'll talk about that in a bit, the IPCC co-authors, students and postdocs, which are the fun part of my day. So I hope to build out more connections there. And of course, friends and family that have tolerated the long nights and weekends working on things. And then finally, ACLIME, which is a project, Alaska Climate Integrated Modeling Project that we've been working on now for over 6 years, includes a growing group of people, and is a lot of what feeds a lot of the knowledge and information and understanding about solutions that we'll be talking about today. And how's my volume? Can folks in the back hear me okay? Okay, I'm getting one no from my husband who's sitting back there. Everybody else. Thanks, Sean. Thanks. But I will try to project more, and if I get a little quiet, just let me know. So I wanted to just start just very briefly with an overview of sort of the climate change setting. And we've already had a couple of really fantastic talks in this seminar series that talk about those changes and impacts. And so I won't spend a lot of time on that. We're going to transition pretty quickly to what we can do about it. But I wanted to put this plot up. I found it compelling because of the kind of visual strength of it, the idea of the stripes, of course, but also because when I looked at it, this is temperature change in the North Pacific, I realized that the majority of my lifetime has been spent in the red above the line there. And actually looking at it further back, the trajectory of change, just if you draw a kind of visual change there, dates back to well before when my parents were born. So I have never known the North Pacific that has not been under change. It has been a process that's been impacted by climate change for a long time. And now we're seeing those processes emerge. Now they've reached a point in many regions where we're seeing impacts of that. But if you follow that trajectory, it does start well before many of our baselines. And that's an important thing to remember as we kind of go into some of the science. And in fact, the baseline that the Intergovernmental Panel on Climate Change uses does date back to this pre-industrial baseline in order to demonstrate and look at the potential changes that are driven by anthropogenic climate change. Now, before I did the work on the second working group here, which is the middle volume, I didn't quite appreciate the structure of the IPCC. And so I just wanted to quickly introduce it. That way, if you want to go find some of the information later, you know where to look. There's 3 volumes that come out in each cycle of the assessment report. The assessment reports turn over at about every 6 years. They started back in the 80s, and they are composed of Working Group 1, which looks at the physical basis, the atmosphere, the oceans, physical changes, and in this year's, in this most recent volume, extreme events. And then how those hazards then map to impacts and risk is captured in the second volume. That's the one that I was involved in, and increasingly chronicling and documenting adaptation, responses to climate change, and the effectiveness and feasibility of those adaptation actions. And then working group 3 picks up with mitigation, carbon mitigation, pulling, recapture, of course, pulling carbon out of the atmosphere, but also processes and things that limit and curtail the deposition of greenhouse gases into the atmosphere. Working Group 1's report is a sobering read. They have increasingly found more and more information and evidence that leads to statements beyond it's probable or it's likely, all the way to now terms like it's unequivocal that human influence has warmed the atmosphere, ocean, and land. It is an established fact, is another term that comes up in that report. Those changes are unprecedented over many centuries to many thousands of years. And importantly, I just mentioned that they looked a lot at extreme events. We are now seeing studies that can show the connection between climate change and extreme events. So we've known for a while that there's probability they're related, but now there's attribution studies that show that these extreme events are occurring, that many of them are climate change caused or exacerbated, and that it's happening across all regions of the globe. So the basic takeaway from Working Group 1's report is to understand the temperature change to date and where we're going. So the very first bit of information, and this may be a little washed out, so I apologize, but the key is that over that pre-industrial baseline of 1850 to 1900, the global temperatures across all seasons, all regions over a 10-year period, recent 10-year period, are approximately 1.1 degrees warmer than they were before we started to have these sort of atmospheric depositions of carbon. Doesn't sound like a big number until you start to look at the baselines historically relative to that warming. So when we look back at a time series from now, back 2,000 years, this rate of warming is unprecedented in the last 2,000 years. It's the warmest multi-century period in more than 100,000 years. And the CO2 concentrations that we have right now, 2019, are the highest they've been in 2 million years. So we are in it. We have exceeded the conditions that we have, as a human society, been accustomed to and adapted to. And there's multiple lines of evidence. This is just one of them, the counterfactual kind of simulations where you take a model and you turn on and off humans in that model. And it just demonstrates, it's one line of evidence demonstrating that human activity is causing warming. Warming is not universal across the globe. Of course, there are different regions that warm faster. Oceans and land are warm differently. And the Arctic, where I work, is one of the areas where change has been most rapid. In the report, they report 2 to 3 times the global average of global warming levels, but new evidence is out that shows that's actually not linear, and that in fact, it's since 1979, 4 times the global warming levels. Associated with that warming, of course, marine heat waves, increased intensity, frequency, and duration. And then as we look forward, depending on the trajectory we're on, these may be once to every 10-year events, where they used to be once every 100 to 1,000 years, or they may be the new normal. And of course, we are now seeing evidence that those extreme events are tied to fisheries disasters. We see an increasing rate in fisheries disasters. So now we have begun to see the chain of custody of climate effects through to livelihoods and coastal communities. Because of the linear relationship between global warming and CO2 emissions, we can use that information to understand the future trajectories that we may be under, given different actions at this point in time regarding carbon mitigation. These are standardized across the modeling community using these terms from the last report, shared socioeconomic pathways. You'll also see sometimes representative carbon concentrations. Essentially, these are standardized scenarios of how the future may evolve. They include storylines that have things like, does everybody become a vegetarian? And do you Do you cut down all the forest? Is there a lot of investment in energy or in sort of renewables? And those storylines become the basis for these trajectories of temperature. And we then can take those trajectories of temperature and map the decisions that are happening at the global level to the impacts at the local level. And that's really important. The other important thing is that they're not prescriptive. It's very tempting to see where we are, which line are we on? Are we on the red line? Are we on the blue line? But the idea is not to prescribe any probability to these, but to lay them out and consider individually the relative risks and impacts associated with each. And so, for example, from these, we can then derive things like what are the potential changes in Arctic sea ice in September, and understand that because there's inertia in the system, we will continue to have sea ice loss, even under the most optimistic of these carbon scenarios, but that might level off in the next 20 years if we can motivate the global community to act. The other thing these standardized scenarios allow us to do is compare relative changes between maybe, I guess you'd call it best case, worst case scenarios, where we have significant carbon mitigation and less warming versus those where we have lower levels of carbon mitigation. This is declines in benthic biomass projected from a global scale model. And I know William and Nate also talked quite a bit about some of these projected changes. And similarly, we can look at projected impacts on fish biomass in the future and look to see if there are regional differences in those and magnitude. Of course, those projected changes in fish biomass also lead to differences in food availability, nutrition access, and food security. So it's an important discussion not only for those global levels in the IPCC report, but also for regional food security and nutrition. All of these impacts are detailed in the report, and this is a nice graphic from the 3rd chapter of the Working Group 2 report, which has pointers to each section of the chapter that talks about the different impacts that are taking place. They're chronicled there. The evidence base for these impacts is listed, so I'm not going to go into it. Here, I want to get to the solution space and talk a little bit about what we can do in terms of adaptation. So one of the key findings of the Working Group 2 report is that along with these increased observations of impacts, we're seeing more and more adaptation reactions and responses. So adaptation is underway. It's already happening. People respond, species respond. But most of that adaptation is reactive, it's uncoordinated, and it's uneven across regions, communities, and sectors. And because of that, there is inequality in the adaptive scope for dealing with these climate impacts. What's needed is planning and coordination in order to make sure that when somebody's adapting over here, it's not causing additional impacts on the other side. But planning and progress in planning is lagging. It's lagging these impacts. And the reasons for that are somewhat complex, but it really has to do a lot with both the psychology and difficulty of planning for something as big and daunting as climate change, the politics and geopolitics that are involved, and things like psychological distancing. Climate change is something in the future. It won't impact me now. So the need to address this is still a priority, but it's not number 1. Maybe it's number 6 on the list. And then finally, more and more dire the projections and impacts sound, people sometimes shut down, and that can create fatalism, hinders action. It can feel like there's nothing I can do, so I'm not even going to put energy into trying to figure this one out. So this is a map from the from our North America chapter that shows the estimated percentage of adults who think Earth is getting warmer. Gray is, we left it gray because we didn't have the studies for those regions. But one of the key takeaways is that obviously we see some difference between Canada and the US in this 2018 study. Oh, and I was just going to say the key here is really to address that barrier, that psychological barrier, is to take this information from the impacts and the risks and translate it into action. So confront that feeling that it's too far off in the future or there's nothing I can do with the information about how to adapt, how to plan, and how to make decisions today based on a considerable amount of uncertainty about the future. So we'll talk about that in terms of fisheries management. But the key for this map, I think, is really interesting is when you lay it next to the observed temperature changes to date, you can see that there's some patterns here. Regions where warming has happened the most are regions where people believe the world is getting warmer. So there is an element, an opportunity in this time period where these climate impacts are emerging for us to present and plan for climate change and take action, because now it's coming out of theoretical and into people's lives. And I think everybody in the room probably can point to something, wildfire smoke or other impacts that have been linked to some of these changing climate conditions. Once we have that identified, the key here is climate attribution, making sure that there is that linkage. There's a lot of things that can lead to increased wildfire smoke. Climate change may be one of them. Forestry practices, for example, can be another. So understanding the component that is driving it from climate helps the planning process. And then finally, using alternative scenarios in the future allows for planning that can accommodate A, B, and C. Contingency planning, testing methods and tools that work in all or the most likely future scenarios. And then we can start the discussion with folks, with policymakers, with managers about how future impacts and risk depend on those actions today, and we can demonstrate it. And that's what we're trying to do. Because I talk about risk a little bit, I just wanted to take a minute to talk about the kind of elements that risk is defined in a lot of different ways. And there's many different definitions, but the IPCC uses one that's based on this kind of they use a pedal plot, but it doesn't scale right when you want to adjust it. So I use the 3 axes here: hazard, sensitivity, and exposure. And the combination of those contributes to risk. So that's the risk space. And so there's different actions you can take. You can reduce the hazard through mitigation. So you can reduce the strength of the hazard that makes your risk area smaller. You can also employ adaptation. And then that risk that remains is something we call residual risk. So the remaining risk after adaptation. And there's also a concept of maladaptation that you'll sometimes hear, which is where maybe that adaptation action was, I'm sensitive to wildfire smoke, so I'm going to go out and buy 30 air purifiers and I'm going to run them off a coal-fired generator. So now I'm actually increasing, it's a silly example, but you get the point, you're increasing emissions and therefore increasing the hazards. So you're actually increasing risk through adaptation. So one of the key things is to look at those adaptation actions and see how those outside of the study focal area or the study system, consider those non-intuitive interactions that could result in maladaptation. And then finally, because we like quantitative things in these walls, the other thing you can do is you can assign some uncertainty to each of these components that go into your estimate of risk. So risk is itself the potential for an adverse reaction or consequence, but it's not necessarily the probability. Sometimes we use it interchangeably with probability, but in the IPCC, it's the potential for that, and the uncertainty and magnitude come in terms of the uncertainty in each of these focal components. So now you can say we have high or low confidence, or there's a 30% chance that the risk will be large of this event. And then this was coined the risk blender by Sean. I thought that was a good one. You can take all of these components, each of those axes, and consider the human, the ecological, and the climate conditions that may contribute to or lessen each of those vulnerabilities and sensitivities or exposure. So that's the IPCC framework for risk, for impacts. And now what I want to talk about is effective adaptation. So for effective adaptation, one of the things to consider is not just the numerous adaptation actions that can take place, but the resources that need to go into it, the time scale for them to be implemented, and the factors that may limit their effectiveness over time. So what works today may not work 20 years from now if conditions are changing. One of the key findings that was universal across sectors and regions in the report was that adaptation needs to be coupled with CO2 mitigation in order to be effective in the long run. Without that, so it lowers residual risk, and the certainty of those adaptation actions being effective in the long run declines as temperatures increase, as CO2 levels increase. So the combination, addressing both the source of the hazard and the adaptation responses, is necessary. I liked this summary. This is from the third chapter on oceans, and it is a packed sentence. It has basically the entire building blocks of effective adaptation in it. So adapting to climate change depends on society's ability and willingness to anticipate change, recognize its effects. So we have to be able to identify that technologically and other ways, and then plan to accommodate its consequences and implement a coordinated portfolio of informed solutions. Easy cheesy, we can do this. All right. One of the things, of course, that's universal across many of these sectors and regions, including fisheries, is that there are these common barriers that come out of the woodwork when we try to go down this route, starting with that willingness, ending with that coordinated portfolio. I really liked this infographic from this paper. The paper interviewed practitioners across different, both tribal, federal, state governance, and they came up with common themes for barriers to adaptation: political action, governance, uncertainty in the projections, needing to improve communication, and increasing capacity, financial and other. Those are common throughout the adaptation actions that we try to implement, and thinking about those barriers and designing adaptation that addresses them is key. This is another nice summary graphic from the report, and I like typologies. I like to organize things. So something like adaptation is can feel very intangible. So it's nice to kind of put it into a few boxes. And so that's what they've done here. And I think it's very nice. It's building off of a lot of the adaptation literature and frameworks that have fed into the report. But the basic idea is there may be social and institutional adaptation. There's maybe built infrastructure and technology, and then nature-based solutions, which ecosystem-based management is one of those, have emerged as a common theme from the report. But of course, a lot of these are interacting, and there's elements you may pick and choose and combine them together. It's not necessarily that they're individual, they're displayed as such. And for example, the first three in this: knowledge diversity, social inclusive policies, and participation, I would argue those need to be woven through every one of these boxes. Your ecosystem-based management is going to be better when it considers multiple perspectives, and when it's designed not just to benefit one group or that's in the room. So inclusive approaches and participatory methods are really key. And so those, I would say, weave throughout the rest. But what I'd like to do is just kind of step through a couple of examples from each of these and talk about the barriers and just give you a flavor of it. We could spend weeks going through this. And so I wanted to just demonstrate some of those examples. This is a fantastic paper. Of course, Mary is here at the school. And the paper, if you haven't read it, I'm sure a lot of people in the room have, looked at the effects of climate shock on crab fisheries along the coast. The crab fishery got shut down, and it had an impact on communities that differed up and down the coast. And the sort of common things in the communities that were able to weather that climate shock was an ability to diversify, and mobility was a big part of that. So this figure from the paper shows the difference between large and small vessels. So the ability to access more resources also comes into play. but also the social cohesion in the communities was a big part of it. Whether or not before the climate shock fisheries were diversified or if they were heavily invested was a big part of that. So this kind of high investment in a single very lucrative fishery can be a type of gilded trap. We've heard examples of that from the East Coast with lobster. That becomes a bit of an issue when you start looking at some of the tools that we've had in our toolbox for sustainable fisheries for years, including catch shares, which have stabilized fisheries. They've made them more safe to execute. They're in many ways one of the key components of sustainable fisheries, but they do limit diversification. And so if the target fishery of that catch share is one that's sensitive to climate, there could be an increased vulnerability to those fisheries. So thinking about how to harness both the power of that tool and tweak it, modify it to adapt to climate change is an important discussion that's taking place in our neck of the woods. Another example from built infrastructure and technology is early warning systems and seasonal and dynamic forecasts. This is something that many of us are really interested in. We, of course, have had a marine heat wave in the Bering Sea. We had a record low sea ice extent in 2018. It's the lowest sea ice extent in a 5,500-year record. This study also found that the patterns of sea ice in the Arctic lag atmospheric carbon by 2 decades. So what happened in 2018 was related to the conditions of the atmosphere when I walked out of these hallways years ago and graduated. So there's some inertia in the system. Clearly, we have to plan for these events coming forward, but we don't know exactly when they're going to materialize. And they have a big impact. So this is PCOD, Pacific Cod distribution in 2010 from a survey, and then 2017 and 2018 during these low ice years. And the blue, the red there is the cold pool. This is where the sea ice had been. It kind of leaves this pool of cold water during the summer. And then the blue is where the fish redistributed. So you see that they moved northward. It's a long ways. They moved northward very quickly, 1,000 kilometers in a year. And it affected the fishery. Had we had something like this linked into distribution models, we might have been able to say, okay, we have a 1 to 12 month. This is an operational tool, by the way, that just rolled out from some folks down in California. Predicts heat waves, and you can set your initial date today and predict out a month or 12 months out, and it tells you the skill. If a tool like this was linked into biological models, we would have a little bit of an additional heads up. We reacted pretty quickly with management, but there is a lag and there is a cost to that lag. So having a bit more insight into what's coming is a key component of adapting to climate shocks and climate change. And of course, having a little additional understanding beforehand of those linkages can help build some preparation for some of the large-scale events that we think may come along with climate change. So that now brings me to the heart of what I work on day to day, which is the sort of marine. Now we're down in the nature-based solutions, sustainable harvesting, climate adaptive management, and ecosystem-based management. And so the key kind of elements to climate ready advice include that ability to react in real time, emergency response, triage. We just talked about the ecosystem foresight, and then planning and developing a system that is robust to climate change and evolves as our conditions evolve. And we call these climate smart decision support tools. It sounds smart. And that includes things like climate enhanced stock assessments, climate informed advice, dynamic management. That could be things like risk assessments in the near term or long term of probability of decline or increase. And it's really built around the idea of coordinating science towards bringing in ecosystem information, bringing in observations of climate conditions into the assessment cycle so that we can help build a system that predicts something like a marine heat wave driven change to fisheries resources. And of course, all of this is based on a robust monitoring and research portfolio that can help us establish those linkages. And when we talk about that final cog, there's different scales. So depending on the region, a portfolio of effective management actions may include any mix of a dynamic or fixed or adaptive component. Some of these fixed measures are designed to incur protection, conservation of areas, for example, MPAs, and they're not easy to move on purpose. They're designed that way to be robust to changes in political will year to year, for example. And so mixing those in with dynamic action, dynamic management, and adaptive policies is a way to bring in some climate-informed advice. And I can go on about that for a while. So what I'll do is just give you a couple of examples, and we can maybe talk about them in more detail during the question and answer. So for example, at a near-term scale, one nice set of studies that's coming out of the California Current is dynamic ocean management. So this is near real-time satellite so satellite data is brought into biological models of distribution, and then that's used to predict the risk of bycatch. That information can be viewed on the web, it can be pulled up by resource managers. And what they did in the study is they actually looked at the performance of a closure area. So they have a fixed, it's not fixed all the time. They close an area for a given period of time for leatherback turtles. They compared that to one where those closure areas were dynamically organized around the distribution of the species, and looked at the performance of the dynamic versus the static. And they found that you could close a lot less area and still protect the non-target species. And that's, of course, with perfect execution. So you want to build on this in terms of the risk of not having the information correct and those sorts of things. But it demonstrates the potential to have closure areas that follow the distribution of the protected species. Another example is the works that we've been doing in the Alaska region. Those of you who have seen a talk by me in the last couple of years will recognize this slide. This is that Alaska Climate Integrated Modeling Project. The goal here was to link up climate projections, hindcasts of conditions in the Bering Sea, link them into indices that fed into a series of single species, multi-species, ecosystem models, and link those models to social and economic models. And the goal is not only to project what potential changes may be occurring, but really to get at the second question: what can be done, and what is an effective adaptation measure, and how does it perform in these different futures? We have a suite of models involved, a ton of people working on those, and the fundamental goal is to identify those effective management actions and identify sources of uncertainty that might be resulting in the performance being different across those. The key component to looking, and you can imagine there's a lot of scenarios that we all could come up with if we sat down in a room and said, let's look at this, this future set of scenarios. The key to finding ones that are meaningful and useful and actionable is to talk to the folks that are going to be using them. So part of this project has been to have workshops that directly work in the council process and generate the ideas for the scenarios that we're going to evaluate with the project. So an example of that comes from a paper that I did share with some of the students before the talk, where we looked at an ecosystem-based management camp. So we started with a ROMS regional ocean modeling system, model of the Bering Sea. On the left is observed, on the right is the model. We said, okay, it's doing a pretty good job of capturing this cold pool of area that we needed to capture. We looked at the projected changes in things like bottom temperature over space and time, and then projected changes in other elements of this lower trophic system that it models, including things like euphosid biomass over time. And we did that under contrasting future scenarios. We also looked at things like changes in the timing and phenology of blooms, and created a suite of indices that fed into a multi-species stock assessment model. That model then was being driven with these indices driving both recruitment, growth, and mortality in the model. And then using some of the feedback from the council about which scenarios they wanted to see, we set up a contrasting set of simulations that looked at the effects of climate change under 2 million ton cap, or if you removed that cap and you didn't have it in the system, and catch just equaled ABC. So this is projections of unfished spawning stock biomass under the moderate and the low mitigation, so medium warming, lots of warming scenarios for pollock, peacock, and arrowtooth. And the other thing we did, because we're trying to capture sources of uncertainty, is we didn't just use one climate projection. We pulled an ensemble of 3. It was a dynamic downscaling, so that just reads lots of computing time. So we were able to grab 3 and then simulate some of the error around those parameter estimates. We see declines in the 3 species. These declines do not account for adaptation like shifting northward. The next thing we did is we looked at the difference. So now we're looking at difference in catch over time between the scenario with the cap, which are the thicker lines, and the scenario without it. And some of the emergent patterns we saw with the cap forestalled declines, but it didn't prevent them. So at some point, the ecosystem benefit of that cap is exceeded by the climate-driven changes to the system. The next is that the cap stabilized catches, so that was good for the performance metrics that the stakeholders were interested in. And the last is that there were species differences in the effects of that. And we could look at we could then take this and translate this into changes in risk over time. So what we found is that risk was lower for ecosystem-based measures, and that risk generally increased over time. And so now I'm just going to take a pause because we have about 15 minutes left, and I wanted to give, those are a couple of examples from things that I've been working on. I wanted to give a flavor of some of the additional kinds of climate enhanced tools that are in the toolbox. I'm going to go through it kind of quickly. So just to give you a sense of it, but if you want to come back, we can come back to it, and I'm happy to send on the slides and the papers as needed. The first is identifying sources of uncertainty. So this is a paper that John Ream led, and he actually did a network analysis to look at and kind of group species by their types of sources of uncertainty. So in this, the blue is sensitivity to temperature. The green is uncertainty due to kind of the linkages in an ecosystem model. The yellow is the effect of a fisheries management. So anything in that group 2 is something that would be sensitive and potentially responsive to a management action to offset climate. And then the gray is random noise. So, you know, reducing that through additional sources of research is effective. He also did sensitivity analysis and found, you know, there's these small tweaks you can make in harvest policies that can result in a 10% increase in catch over status quo without affecting spawning biomass or mean body mass of the whole aggregate group of species. And this is a size spectrum food web model. And then it's going to let you ponder that for a minute while I try to advance slides. There we go. And then another extension of some of the work that we've been doing was led by Andre recently and Mathieu, he's in the audience here. And the idea here is to take those projected changes and link them into profit and changes in yield as well. Andy has done some work to look at ecosystem responses under these trajectories. And this information can reveal things like declines in northern fur seals that we are now further investigating with a larger study looking at setting harvest recommendations based on climate-informed northern fur seal abundances and pollock biomass. We have another nice study that Jennifer Bigman has got in review right now, which looks at potential changes in spawning habitat, and not all stories are negative. So in the case of peacock, we actually found that there would be a potential increase in spawning habitat, and that spawning habitat would shift northward. And then climate enhanced distribution models are an important component of the advice that we're giving going forward. And this is a paper by Cheryl Barnes. And one of the things that she found in this is that while these climate enhanced models, which had habitat features and other things in there, but the dynamic aspect was temperature, what she found was that while those did a better job of explaining skill in the hindcasts, when you turn those forward and try to forecast them forward, they didn't perform better than just a persistence, a general mean temperature model. And there's some similar work from the East Coast that points to the importance that just including temperature alone can underestimate the distributions. And this is something that Cheryl has postulated as well, is that additional covariates need to be included in the models. And so it's a little hard to see, but these are two different species. On the left is the full model, on the right is the partial model with just temperature. And anything red is a good habitat suitability. So if you just use the temperature, it looks like a lot of habitat suitability, but when they used the full model, what they saw was that there was actually quite a bit less habitat suitability going forward. And then another nice example from the East Coast involved looking at projected distances from ports. So again, trying to bring that information into the regional community level so that it's out of this sort of nebulous future scenario and tractable to a community, to a port, so there can be planning to account for some of these shifting distributions. And then finally, we have at NOAA, there's a project kind of in each of these regions that is doing this integrated modeling. This is the Future Seas project. There's a paper out, sorry, it says in press, it just came out today, which shows some of the kind of advice coming out of these integrated modeling projects in California, linking our system models to biological, social, economic models, also using workshops to help inform questions that are being asked with the integrated system. And so I won't go into detail here in the interest of time. I kind of want to get to the last part, which is the mitigation. But they are finding, again, some interesting evaluations of things like dynamic versus static closure areas and changes in suitability and habitat for things like albacore, which they're seeing increases potentially under climate change. So there are both negative and positive stories that come out of some of these evaluations. And identifying those is important for building adaptation that can allow people to switch to species that may do better under climate change. The goal is to, if we think back to building adaptive capacity that is moving us out of the reactionary realm, the goal is to invest in structures like this across the US and build that adaptive capacity into our day-to-day activities. And so this is the Climate and Ecosystem Fisheries Initiative, which is going to be deploying these high-resolution models in each of the regions of the US and providing the foundation to build those climate-linked ecosystem models. And for the students and postdocs in the room, also providing FTEs. So stay tuned. And then, of course, once we produce this information, you need to build the structure on the other side and the management side to take it up. And we've been involved with, along with Diana Stram, I've been involved with the Climate Change Task Force in Alaska. And the goal is, this is the council's task force, and the charge is to identify how fisheries management can be more adaptive to climate change. And so there's these kind of on-ramps that have been identified that range from near-term tactical to long-term strategic. And they're forming the discussions of how to change business as usual in the management. It's incredibly exciting to be part of. It's also incredibly daunting because the science becomes the foundation for those discussions. Okay, so the last thing I just want to end on, I've got maybe 2 or 3 more slides, is to talk about that even with all of these exciting new innovations and solutions, carbon mitigation underpins the ability for these adaptation measures to be effective. We're constantly going to be changing the way we do things at a rapid, more and more rapid pace if we have a considerable amount of change coming. So slowing the amount of change is necessary to ensure that adaptation measures are effective, or at least to increase the confidence that they will be. The way that the global community is started to do this, it's exciting. I won't bury the headline, it's not quite enough, is to do have specific targets for carbon emissions. They're linked through a collective agreement, the Paris Accord, which has 3 elements to it. One is to limit the global average temperature to less than 2 degrees. The second is to enhance resilience through adaptation and investment in planning. And the third is to identify the financial sources to allow for adaptation. The indices rolled out during the Conference of Parties in 21. Unfortunately, you can't see it. Well, it's above that red line there. Sorry that it doesn't show up there on the screen, but the original indices had us overshooting this dotted line, this pink dotted line of SSP 4.5. The reason that's important in our neck of the woods is we found higher risk. We found more crashes, less effective at adaptation measures above that dotted line. So not adhering, even adhering to the indices that were originally the carbon development goals that were initially agreed upon would have had us in a realm that wasn't sufficient. The red indices here are the revised targets. This is where we need to go, according to the science. The risk is lowest. Adaptation measures may be able to address climate effects if we can stay on the trajectory of 2 degrees. So we are doing better. We are now in the realm where some of our studies say maybe it'll be okay, but to get to that target of the future for the Paris Accord, additional measures need to be taken, and they need to be taken this decade. So the report also found in Working Group 1 that the central estimate of crossing 1.5 degrees Celsius of global warming occurs in the early 2030s. So it's, 5 years away, 3 years away, 2 years away, according to, and maybe 3 years ago, according to the error bracket for that time period. And in order to remain below 1.5 degrees, the policies to do that need to be implemented now. So this is the decade of action. You've heard that probably in the press. The reason is because the measures for us to stay on a trajectory that stays below these targets have to happen now. And this is just that in words, but the key takeaway when you read the Working Group 3 report for me was it's possible. So it's not, we have in place already the studies, the technology, we have, we know what we need to do, we know the problem, we know the source of the problem, and we know that people have done in-depth economic analyses. We know that the net benefit, there's a net benefit to employing this. There are methods to do it equitably to limit carbon. And if we implement these policies we already know about, in addition to the ones that we're developing, we can reduce global emissions by 40 to 70% by 2050 and have global greenhouse gas emissions by 2030. So it is something we can do. And the key to implementing that is to generate the momentum to do it, tying our research with climate change back into some of these trajectories that relate to these targets that nations are setting is really important. So not only taking those projections down to the regional scale, but communicating back up what that means to policymakers, to our national leaders about the importance, the reason why it's important to adhere to these targets. And so with that, I'll go ahead and stop. I think we have a few minutes left for questions.
Dynamic, active, and fixed management.
Yeah.
I was wondering if you've given examples on active management, what that looks like.
Oh, adaptive management. I probably said active. Sorry, I was rolling a bit fast. So adaptive management is one of the central tenets of a lot of the management we do of fisheries in the U.S. And the idea is that you set a target and you go monitor the system. You come back and you reevaluate in a regular cycle. And in many areas, that's every 1 to 3 years. And then you adjust. So you don't just say, go out and you can have this much, harvest for 10 years, but you actually revise that estimate regularly as the population's being fished down. And that allows for adjusting course and weathering some of the climate variability that's inherent to the system. It's obviously a core component to effective management under climate change as well. Good question. Yes.
Does lower ice cover provide more area for current fisheries? And do the current fisheries folks see that as an advantage that there's more area they can fish in?
For the last question, it's a good question. The latter one, I'll try to ask at the next workshop. I think that would be a good one to ask somebody who's doing the fisheries operations. But the first one, yes, the lower sea ice does provide access. So part of, I didn't get into this at all, but part of that redistribution of fish northward is that they moved into an area where bottom trawling is not allowed. You can still do pelagic and pot, but you can't trawl on the bottom. And that area was largely, and Jim's in the room, so he can probably correct me if I get it wrong, but that was largely because those areas aren't really very accessible at the time it was established because of sea ice. So when you have total loss of sea ice, now you have access to the resource and fish are moving to the resource. There's an interesting, another example from shipping. So shipping across the northern regions has increased, and there's actually an increase in risk in the intermittent. So there was no risk when they didn't go, right, when there was ice. And now that the ice is broken up, there's an increased risk because they may encounter, they may get locked in by the ice, they may have ship strikes and things like that with the ice. And then it actually drops back down when there's no more ice anymore. So there's this intermediate risk also that can happen with some of those physical changes.
The paper where it was looking at one of the considerations was the with or without the 2 million ton ground fish cap. Was there any analysis done on what it would look like if that cap was reduced?
So it's spot on. It's one of the things that we want to look at. So what if you had that fixed cap and then maybe you had something dynamic below it that was a function of temperature or other covariates, and how will that perform? So that is one of the ones that we're hoping to look at. And I think, Jim, I don't think anybody's looked at it to date yet. So yeah, so invite Jim next year and he'll tell you the answer.
So some North Pacific, some things have done well, like soft salmon, some things recently done very badly, like mussel crabs.
Yeah.
So sort of projecting forward, are there any species that might do well in the future and sort of offset some of the things that are going to do badly in the future?
Yeah, I think, and it's region dependent. So yes, is the bottom line. There are some species that will do better. I would say that some of those have come as a little bit of a surprise. So the difference, you mentioned sockeye salmon. Sockeye salmon have done really well at the same time that Yukon Chinook have not done very well at all. They've collapsed. And so the difference in the nuances of marine survival and where the nearshore habitats they're using, it really becomes an important factor. And so one of the challenges I think we have in trying to anticipate who are the winners or losers, and that is that we, in some ways, we're well outside of the boundaries of what we've known, and we're trying to use that to predict forward. So what I think is somewhat of a more effective question is to say, how would you, if you didn't know exactly which species, but you need to change and adapt through diversifying your fishery, what types of fish can you, what does your gear allow you to do? And then look at whether or not that portfolio species all have high risk, or if there's some that seem more resilient, and just make sure you're mixing in. There's going to be some that are super valuable, but maybe very, very sensitive. Mix in some that seem, maybe they're not as valuable, arrowtooth or something, but they are more stable, right? And build a portfolio that way. But it's a good question. We should start like a it should be like a rolling game, a poll to see who's right. Yeah.
Yeah, so I had a question about the Arctic cod up north. I mean,
Yeah.
it's a northern subspecies, but have you ever heard of like managing those types of species? Yeah, because I realize that sea ice extent actually does correlate with them, but if the sea ice decreases, they just migrate
Mm-hmm.
or just decline. So are there ways of like managing those types of species?
Yes, so there's a couple of, it's a good question. So there's a couple of important things. First, Arctic cod are extremely important for the communities that rely on them for subsistence resources, of course. And then there's this moratorium on commercial fishing in the Arctic waters, the far north Arctic waters, so beyond the Bering Sea, that is designed, the agreement, which actually was put into place on my birthday in, oh, now I'm going to forget the year. I would say 2020, I think. It might have been 2021. Gives something like 13 years to do the research to understand the effects of opening fisheries in the region on the ecosystem, and there hasn't been those large-scale commercial fisheries in the region. So right now there's a whole international set of dialogues with fisheries managers, center directors, and people that are involved with the Arctic, planning the science to ask that exact question, to answer those questions about what if the fish move, but also what if you're harvesting them and you have a commercial fishery for them. So it's a good time to get involved in it, and it'll be interesting to see what happens in terms of the commercial fisheries if they do take place there. A lot of that ability to harvest them will depend on the types of fisheries that are put in place, where processors are located, and things like that. And if the Arctic ecosystem can support that kind of level of exploitation.
Thank you.
I think you had a question.
Yeah, I guess related to both those last two questions is, if we're interested in the Eastern Bering, shouldn't we be modeling something bigger than the Eastern Bering to look at what's happening, say, at the northern edge of the Pacific and the Gulf, and what's going to spill over into, in large part, is an arbitrary boundary that we've drawn?
Absolutely, and it's part of. I'm smiling because I would like you to ask that question of the NOAA leadership, because where we're trying to do is build these grids for the base oceanographic models that span from the Gulf of Alaska all the way into the Arctic. So you can get at those questions of, the boundaries ending somewhere around the Aleutian Islands doesn't tell us much about what's coming up from the south potentially. And so that's the idea, is to try to expand that oceanographic grid, and then build on to that the species distribution models, because that's where most of that movement comes from. A key component of that is some of the work like Ingrid Spies has been doing with genetics and understanding and tagging as well. Sandra and others have been tagging fish to see where they go. So do they follow the currents? Do they go through the Aleutians and come up into the Bering? So yes, 100%. The domain that you focus on limits the scope of the answer that you get out of the study. So it's important to extend it. Yeah. And we're working on that. So our next set of iterations of simulations has the northern Bering. So that's at least a step forward from what we were doing before. We didn't know when we started the study that it was going to happen that fast.
Yeah, thanks, Kirstin. Great talk as always. There was a quote you pulled out of the FPC that it's got a lot in there about adaptation. And right in the middle of it was predict impacts. Yeah. And I went, yeah. My sense of a lot of the big impacts are just totally surprises. And I wonder, since you're in this realm, what do you see as the benefits and then the potential maybe risks of scientists saying, hey, this is the trajectory we predict, versus saying,
Yeah, well, I think I'm 100% with you on the predict. So predicting isn't, I think anticipating is different, right? So anticipate that there may be a change and plan for it. If it doesn't manifest, continue course, but have something in the toolbox to know how to respond. That's part of that is understanding where things may go in terms of trajectories, but those become the basis for discussions about what to do, because they are 50 years in the future, and it doesn't necessarily what's important is knowing that is one of the realm of possible directions for species to go. But planning for today, our fisheries management, uses 1 to 2 year trajectories to set harvest. So use that to understand, well, if you're constantly, Cody has a new, Suzalski has a new paper, gosh, I hope I said this last name, has a new paper coming out that looks at kind of chasing the baseline, right? So if your vision is only 1 to 2 years out, and you keep adjusting, biomass is going down, the target is continuing to decline, you're just going to chase the resource into the ground. Understanding that fixing a target, using these climate simulations to show that if you fix a target that is climate naive, and then use your current status to that climate naive, is a better approach, is something that needs to be brought into the discussion. So you can have these. I mean, we were sitting in the plan team and is thinking, we've been doing these simulations about some of these maladaptations. You don't even know you're doing it, and you're adapting in time. You don't have the kind of vision of the longer term. So that's where the advice, not the prediction of there will be 23 fish in area A, but if there were 23 fish in area A and you kept adjusting your baseline down, you might run the risk of overfishing faster. So that's the kind of setting it up as a scenario for conversations and contrasting against different climate futures provides more, I think in our experience, more valuable information than the point estimate. But everybody wants to know what the world's going to look like. So you do have to do a little bit of that too. Yes, Jim.
Yeah, great talk. Just a plug for the workshop that the council's putting
Oh,
on
good,
downtown.
good. Yeah.
We'll be addressing some of the questions that came up. It's basically the fisheries, Arctic, Chuck GC changes. And it's February 7th and 8th. It'll be at the Renaissance, but the details are available on the council's, City Council's website.
Yeah, exactly. And they'll be asking specifically for examples of some of the climate informed management and trying to build scenarios that they can use to modify what they're doing. So it'll be a good workshop, I think, and hard discussions. So thanks. I should have put that on there.
All right, well, thank you one more time, and then there's your